Good afternoon, everybody. So here's my second video where you have an equation with cosine with 1, 2, 3 different transformations. So the previous video I had sine and I wanted to do one with cosine just so that you have that experience. On this one, since I'm using the same method to find the new angles, the midpoint, I'm not showing as much work. It leaves me some space. And the work is the same as in the previous video. But if we start at the very beginning, so the amplitude is 3, so that means my high point is 3, low point is -3. I take the coefficient of x here, I divide that by 2 pi, so I know the length of my period is pi. Again, it's shrinking. And the minus pi over 6 translates to a horizontal shift pi over 6 to the right. So just like in a previous video, I have my NSP, my new start point, my new end point. I find this one by setting it equal to 0, and then solving for x. So my new start point is pi over 12. And if you look at this over here, my new end point, I set equal to 2 pi. I want to show you something quickly here, just to make sure you're clear on my work. If you look at the second to the third step, I can easily transform going from here to here by doing this. 6 times 2 is 12 pi plus 1 pi. That's 13 pi. That's my numerator. The denominator of 6 stays the same. And think about this. Since I have a fraction here, I multiply by 1/2. So then that's why the denominator is 12. So here's my new start point. Here's my new end point. And just like in a previous video, if I want to find the midpoint between these two, I add them up and multiply by 1/2. So an easy way you can do this mentally is they have the same denominators. If you see this right here, if you add the numerators, that's 14 pi. And then you can cross cancel, so that becomes 7 pi and then over 12. Right? Now for the other two angles, I didn't show the work because it's the same thing. You're using the midpoint theorem. So again, you add these up and multiply by 1/2, so you get 4 pi over 12. If you want to reduce that, you can reduce it to pi over 3. And then the final one, again, you add these up, so you get 14 pi over 12 multiplied by 1/2, and you would get 10 pi over 12. I'm sorry, I said that wrong. Let me say that again. Let me back up. If you add these up, you get 20 pi over 12 multiplied by 1/2. You get 10 pi over 12. And if you want to reduce it, you can reduce it to 5 pi over 6. Right? One thing that I forgot to mention that I always want you to check, if you look at the start and end point, the distance between these two, if you subtract them, you're going to get 12 pi over 12, which is pi, because the length of your period should be pi. So I'm going to turn the whiteboard around, and what I have is I have the full graph of this over 2 periods. So one where you're moving to the right, the other to the left. Where you're moving to the left, I don't have a lot of the work because it's the same thing, and I think by now hopefully you can do that work on your own. I will be explaining a little bit, but not a lot. So I want you to take a look at this here. Okay. So your new start point is still pi over 12, just like on the previous side. And I wanted to show you this, the new end point here. I want to show you a quick trick right here. So you'll set it equal to -2 pi, because you're moving to the left. When you add pi over 6, just like I showed you before, what you can do is you can multiply these together. So that's -12 plus 1 pi, so that's -11 pi over 6, and then multiply by half. So then you end up with -11 pi over 12. That's how you get your new endpoint. So I just wanted to show you this trick right here, right? So let's take a look at the second period as you're going from the start point moving to the left. So look at the angles. So you have 11 pi. As you move to the left, you have pi over 24. You have 0, and you have a -11 pi over 24, and then -11 pi over 12, right? So all you would do, what I didn't show, is how to find these 1, 2, 3 angles. But I think now you know the method of how to find these, right? And then your domain is negative infinity to positive infinity. This is a continuous graph. And your range is from 3 to negative 3. Okay? If you want to, you can keep these angles here as is so that they all have the same denominator. Or underneath here, I wrote the reduced form. It doesn't matter to me. You can have either or you can have both. Right? Now, this video and the previous one both contain 3 transformations that you actually did individually on your worksheets. And what's going to happen is the review sheet that I'm giving you is going to have 2 equations that have multiple transformations. So the multiple transformations won't occur on your worksheets, but they will occur on your very last review worksheet that reviews all the problems that you've done at your level, either in integrated 3 or in math analysis. So again, if you have any further questions, make sure you email me any questions. And if it's a simple question, I can answer it via email, or I may have to do another video explaining your answer. All right, so take care, everybody.